All right, good afternoon. I'm Jonathan Moore, and I'm the Director of Fire and EMS Operations at the International Association of Firefighters headquarters in Washington, D.C. The Fire and EMS Operations Department is that tiny little pocket of the International that deals with fire and EMS operations in terms of what the big red trucks do in the street, EMS. We're also the folks that do geographic information system staffing and deployment studies. We have also gotten involved now in the communications aspect of what you do in the street in conjunction with the health and safety folks. That sounds better. The health and safety folks deal with the communications issues as well. What I'm going to do is give you an 80,000 foot review of what we're going to talk about with some real subject matter experts sitting in front of me. I can talk about a lot of things really well, but these are some of the smartest people I know on these topics. So let's just kind of wind back the clock and look at where we were in the beginning. How many of you have used a radio that looked like this? Okay, the last time I asked this, half the room said yes. They must have all retired in the past 2 years, so God bless them. All right, that's one of the original bricks that we had in the fire trucks. And then we had options. This was new tech, right? Now we had handy talkies, so you didn't have to carry that brick, the suitcase. And the Motorola unit you see there has options because it had 2 channels. You could have a dispatch channel and a fire ground channel, and that was a big deal. It still is. You need to be able to switch off one and talk on the other. So that was a big deal. This is, 10 years ago, this is a diagram of a new tech system. This is a P25 digital trunked, whatever frequency you want to assign it kind of system where multiple parts talk to multiple parts. If you can see my mouse pointer, here's a fire truck that wants to talk through a tower to some other switch and talk to dispatch. They may want to talk to each other directly and all in circles and maybe interoperably. So this is what was new tech. How many of you were in your department at those moments when you put in the fancy digital trunked systems and it was brand new? Okay, and then of the folks in the room, how many of you sort of came into the fire service with this magic happening in the radio end of things? Just show of hands, how many people have digital trunk systems now? Okay, is anybody still on low band? Yay. Hang on as long as you can, it still works. Just VHF analog, not digital, VHF stuff, 155 megahertz, a few. Okay, hang on to those as long as you can. Oh, just to point out, those new tech systems that you saw put in or you came into straight out of rookie school, those are now what we call legacy systems because they're old, like us, that started a while ago. Legacy systems, you're going to hear that word come up again, and that is what you have now. How many of you have had system failures? Just put your hands up real high so I can see. That's a lot of system failures. Of those folks that had system failures, how many had bad outcomes? I'm not going to ask what kind, but how many had bad outcomes because their radios didn't work? Only a couple. Well, that's sort of a blessing. A lot of folks got real lucky. This is just a snippet from the news from 8:20, not just a few days ago from Detroit, where everything is broken. Apparently the radios are broken too. And they were so broken, in fact, that in this case the police and fire folks had to talk to each other on their cell phones, which was pretty amazing. Their cell phones still worked. Well, the commercial side wants to keep those cell phones working, so they're working. And they sort of fell back to that as their safety mechanism to talk to each other. So some systems are broken, and it doesn't project very well, but that is a busted walkie-talkie that he probably stomped on it because it didn't work when he wanted it to. To fix some of those issues, there are some other very interested parties out there, one being the government, your Congress, our Congress, that felt like there's an interoperability problem, there's an information sharing problem, and there are radios that are broken. So their suggestion was, let's take some radio spectrum real estate and turn it into a really cool, high-functioning digital data exchange, and maybe voice someday kind of system. And that is what FirstNet is. And we'll talk about that downstream today a little bit. FirstNet, how many of you have heard of FirstNet? How many have not? A lot. Okay, so I'll spend a couple of minutes on that, and then Kevin will make sure we leave you plenty of time to talk about FirstNet towards the end. FirstNet is meant to be an interoperable, nationwide data exchange network for public safety. So instead of your mobile data terminals or your mobile computers using Verizon to exchange data with dispatch, it would use another version of that that is dedicated to public safety. Now, in the end, the system will probably be a blend of commercial traffic and public safety traffic, depending on how FirstNet happens. The important thing to note is FirstNet is only pretty much on paper right now, okay? It's a bright idea that is being translated in chunks and pieces into actual things you can touch and talk on. There is really nobody that can talk or exchange data on FirstNet right now because it doesn't exist. So how many of you, a quick poll question, how many of you have decision makers or are decision makers that would choose to save your radio communications money to plug into FirstNet versus fix your aging legacy critical voice systems? Anyone in the room? I've asked that, but, oh, one. Okay, I've asked that in a few places, and the feedback, the phone calls that I get basically say, our fire chief doesn't want to spend the money on fixing our 800 system because he's going to plug into FirstNet. But we can't talk on our current system. That's okay, because we're going to buy that new stuff. So let's not worry about it. I do hear that in my office, so that's an issue. FirstNet is still a ways out. This is what, you saw, I showed you that old tech versus legacy schematic of radios talking to radios. This is what FirstNet looks like in a cartoon. It's just basically the gold box at the top is where all of the data gets exchanged. That's the magic gold box of data exchange. And then you have lots of different users that find their way into that core to exchange data, and hopefully they get their data back at the other end. Basically, at this point, you can ask a question and you get an answer back, but not so much asking the question, where do I need to go, or can you find me in the basement, isn't part of this picture right now. We'll call it the software or the engineering solution behind FirstNet is what we call long-term evolution. And you'll see and hear these words many times today and many times in the future as you think about your communication issues. Long-term evolution, or LTE, is basically the engineering standard, the engineering plan to make data signals exchange universally across everywhere. And this is the standard that's here and the growing and expanding. When you look at if you have a smarter smartphone and you see 4G or LTE that shows up there, you're using long-term evolution sort of engineering. You will hear the expression VoLTE, or voice over LTE. That is something that will come as well at some point, taking your voice, making it go through your smart device of whatever magic little box that is. It will go somewhere and someone will hear it at the other end. That's voice over LTE using what is principally a data exchange network or engineering now. We'll have a quiz on this schematic before you leave. Got it? Okay. This is sort of interesting feedback from a particular vendor. I think I didn't make it completely innocuous, but this is basically an advertisement for why the public safety community wants to use FirstNet or broadband data exchange. And they certainly paint the picture that you can see there that 90% say real-time data access is important. Now, I'm going to ask a different question. If you had a choice between exchanging an email from the cellar where you had fallen through a floor and you're on fire, or you would like to push a button and say, I'm in the cellar and I'm on fire, How many would like to push a button and say, I'm in the cellar and I'm on fire? How many want to post something to their Facebook? Very good. Okay. Data from my perspective, and this is Jonathan, who is the director of operations kinds of things. I worry about you being through a hole in the cellar. That's my world. I don't really care that you can do facial recognition on me, and I don't care that I can do fingerprints, and I don't care that I can necessarily pass telemetry data, though that's important. It is, I'm pushing the button because I'm in trouble. That's our concern, and that's really the message when I do my speaking time at places. That's my push. So this is important, and it's significant, but it is still important for you to have your current voice communications capabilities. The other sort of buzzword you'll hear over time is the T-band. Now the T-band, as a matter of very brief introduction, if this is a frequency spectrum, so my brother in the back row that had the low band stuff, that's your box. It's all yours, okay? The rest of the folks are somewhere, if I can find my spot here. There we go. VHF, that's the 150s, the 200s, not many of us in the 200s. The 460s, that's what used to be the trunked 400 megahertz stuff. Right next to that, I keep losing my pointer, but right next to that is this T-band piece right here. That used to be television channels. When I went to Northeastern in Boston and I dialed up because I'm a radio geek, right, even in college, I could dial up my UHF TV and listen to the cops. That was kind of cool. Didn't have to have a scanner. I just had to have a TV with an antenna. So that's where those folks are, that UHF T-band. There's basically 11 geographic regions based on 11 major cities that use the T-band for public safety, and they use it very well. It works. It's not terribly broken, and it seems to be pretty resilient, and it works when you push the button and you're in the cellar. That T-band is going away. The use of the T-band is going away for public safety in X number of years. And we'll talk about when that's triggered to happen. The idea is the folks that are in the T-band can go to some other piece of spectrum to free up some space that can be auctioned off to pay for some other things. In some places, they can't get there from here. At least the cities that are underlined here, Los Angeles, Boston, New York City, LA, Boston, New York City, are ones that we've heard from, actually in particular, on my telephone at work, that have issues with moving away from the T-band. How many folks in the room are a T-band city? All right. Red shirt, Boston, right? Okay. So Boston's a big one. Who's New York City? Do we have New York City folks in the room? That's the other big one. And Los Angeles, based on a presentation we saw last week, has a similar issue. They don't really have a place to go to. It is a system that works. It works very well, and we'd like to hang on to it as long as we can. To address some of these issues, including some very technical stuff, we have an expert panel before me. We have Mike Worrell from Phoenix is going to talk about nuts and bolts, melting radios, and things like that. Derek Orr is going to talk about some of the research that focuses on the devices and data exchange kinds of things in the field coming, so future stuff. Anna's going to talk about audio quality, which is integral to you. I mean, a whole lot of this is really important, and we know that. So Anna looks at that, and you'll hear some examples when we get to her, what they know and how things can be fixed. And then we'll follow with Kevin O'Connor, who is our governmental affairs person, who will talk about some of the legislation that has triggered some shifting of frequencies, abandoning the T-band, FirstNet, and things like that. So without further ado, we'll have a little transition, and Mike will come on up. I'm going to trade microphones. Do you have any questions for me with my overview before I hand the microphone off to Mike? And then when Mike is done, we'll give just a couple of minutes for questions for Mike while he's up here. All tangled up and all I can tie a square knot. Do I get a good point? There's that. All right.
Okay, I'm Mike Worrell. I'm from Phoenix, Arizona, and I was on our team that transitioned us from an analog VHF system to a P25 trunk system, and then also kept the analog system because of what we found out later on. But here to talk to you today about fire service communications, some things that are going on. So through our careers, we've seen a lot of things that have come up as technological advances. We've seen digital radio, P25, and some of the issued vocoders associated with audio quality that Anna will address. But a lot of these things, trunked radio systems, multiband radios, and when we look at these things, they've been advertised as this is the solution. Well, has that been the true case in all these technologies that we've seen so far? No, it hasn't. There's times to use the right tool for the right job, and we have to pick one of these tools to use for our communications needs. The last one there, FirstNet, one of the things coming up on the horizon is mission critical voice. And as Jonathan said, that's on the horizon, and some people are looking to that as the voice solution for us in the future. That's press-to-talk voice, where we would actually key up some device and talk through FirstNet to get with our other people on the fire ground. But one of the things that's important to note is we have industry standards that are associated with our communication systems that are in place today. One of those is in FPA 1221, which has to do with system design and system build-out. And one of the things that they require for trunk systems is a direct mode of operation. So when we go forward, going to LTE, we're going to look at some of these existing standards, and hopefully we'll be able to adopt these existing standards into the new technologies. So some of these obstacles to communications that we have, the equipment itself, I mean, when you look at the equipment, the ergonomics of it, the size of the knobs, we're operating with big gloves on, we got face pieces on, there's little buttons, knobs, the things beep, bonk, honk, and do all these other things. But those things are all obstacles to communications, because with all these radios, who are they building them for when you get right down to it? Are they building them just for the fire service? No, they're building them for the whole marketplace. So they design flexibility in their designs so that they can meet the needs of the marketplace as a whole. But what that does for us is that's going to create inconsistencies for us. But the big thing on this, there's no fire service standard for portable radios themselves. Are any of you aware of that? So these are the radios that I've seen through my career. And in the mid-'80s, you see the radios, the flat knobs that you couldn't operate them with a glove. And then you progress up to 2010, bigger knobs, high visibility cases, those kinds of things. But consistently, you look, there's two knobs on the top of the radio, there's a press-to-talk button on the side. So some of those things are consistent throughout. So like I said, there's flexibility in design, but the byproduct is inconsistency. So what does that create for us as in the fire service? Since these radios can be programmed in so many different ways, we need to make sure that we train with our equipment, understand how they operate, because of one button on my radio that works a specific way, I go to another department, it's not going to work the same way. Like I said, the beeps, button, the bonks, the knobs, all those things can be programmed differently. Other program features in a radio are the ID systems themselves. So in Phoenix, I operate on a VHF conventional system when I go into the hazard zone, operate on the fire ground. And when we're doing support function or EMS calls, we're operating on a trunk system. But depending on which system I'm operating on, where my channel knob is my emergency button acts differently. So if I'm on a conventional system, it acts one way. If it's on the trunk system, it acts differently. The ID systems are different, so each radio has two IDs. So this creates complexity within our own system. But those are programmable features. How many use channel announcement on your radios, where the radio will actually tell you what channel you're on? Is that a good feature for a fire guy? Yeah, because when that thing inadvertently changes channels, you're able to know it. So those are some features that are of value to us. Now when we get down to looking at radio specifications themselves, and these are the environmentals, I'm going to focus on those for a minute. The environmental specifications, they all reference Mil-Spec 810. Any of you familiar with Mil-Spec 810? don't see any hands raised. Okay. So mil-spec 810. A high temperature standard for mil-spec 810 is 50 degrees C. How many of you know what temperature 50 degrees C is without looking at the little cheat sheet up there on the top there? I didn't know. 50 degrees C is 122 degrees. How many fires do you go in that are 122 degrees? In Phoenix, Arizona today it's 106 degrees. When I get in my car, it's 122 degrees. So, you know, that kind of emphasizes, you know, what the point is here is these radios are not really designed for the environments that we're taking them in. There's other tests in there, low temperature and shock, drops, those kinds of things. NIST did a study in 2006 on portable radios in the firefighting environment. So this slide, if you look at the bottom slide, you notice something different there. Turnouts, 500 degrees. Pass units, 500 degrees. Tick cameras, 500 degrees. What should the radio be? It should be 500. It's 140 degrees. So hopefully we can change that. So when you look at this, when NIST did this study, they took the radios into these different environments. And so they radio ABC, thermal class 2, they took it at 160 degrees, which is 320 degrees. And you can see, did the radios survive 320 degrees looking at that chart? No, they didn't. I mean, you know, you look at 9.5 minutes into it, the radio's not transmitting. How long are you inside a building? You know, how hot is it? So the radios weren't meeting the environments we're taking them into. Now, when you go beyond 160 degrees C, you know, same kind of thing. You had some case melting, radios didn't work. But a big thing on a radio is when you heat a radio up, they tend to go off frequency because there's clocks inside those radios. When you heat them up, it causes variation, the components in there, so they'll go off frequency. And if I go off frequency in my radio, what have I actually done? Basically change the channel. So who's going to hear me? Probably not the person you want to hear you. They did some testing on speaker microphones. So these are speaker microphones. And the thing to note here is that speaker mic C, you see radio C, is look at the survivability of that speaker microphone. It made it up pretty high. So in conclusion, on the 1477, when they did this study, the big thing, if you look at the bottom paragraph, since firefighter turnout gear is designed to protect firefighters exposed to thermal class 3 conditions, handheld radios should be constructed to handle these conditions also. So that's that 500 degree number we're looking at. There's some other things in there about, you know, protecting your radio. How many of you use speaker microphones in here when you go in? How many of you put your radios in your pockets? Those are good things because when you actually put that radio in your pocket, you're protecting that radio, and that radio will actually operate beyond that 122 degrees it was designed for. So, 2011, June of 2011, some members of a couple San Francisco firefighters lost their lives. These are the radios that they carried in there. Do you notice anything bad about these pictures that you see with these speaker microphones? They're melted. So when they took those speaker microphones and those radios out, the thing to note was the radios, when they actually took them out and tested the radios, the radios actually work, even though you saw some of the case melting, those kinds of things. But the speaker microphones, because the firefighters were dependent on those to key up the radio and transmit their voice out or push their emergency button, those speaker mics had failed. And one failed due to high heat, causing constant transmit. How many have a transmit timeout programmed into your radios? Like if you key up that radio and you just hold it, what happens? Eventually it times out and it's not going to work anymore. Well, the speaker microphone, when it's short, when it heated up, wires shorted in together, caused that radio to transmit and it timed out. And that radio is inoperable from then on. The other one just flat out failed. So what they found was when they did the investigation, they found that, you know, what we were just talking about, the standard is, you know, it only has to operate to about 140 degrees. But what the San Francisco Fire Department did is they requested the NFPA look at making a standard for portable radios. So March of 2013, this year, NFPA 1802, a committee was formed to look at writing a radio standard for the fire service. And what that's going to do is all these things here, but basically we're going to design a radio standard that's going to meet the ruggedness requirements and environmental standards and ergonomic standards that we need for the fire service. If you're interested in that, those are all open meetings. You can go to nfpa.org/1802, and when they put out stuff for public comments or the meetings, you know, you can go there. You can actually attend the meetings if you want to. Those are open meetings. So NFPA 1802 is broken up into 3 subgroups. It's a big task. So they broke it up in 3 groups. One is physical properties, which is the ergonomics of the radio, the size of the radio, the button knobs, the placement, those kinds of things. Looking at that, and they're going to make those consistent across the board, across all manufacturers. Includes a speaker microphone, because what is that speaker microphone for you? Basically, it's an extension of that radio that allows you to keep that radio in your pocket. The environmental standards group, they're going to look at, you know, just what we were talking about, looking at the fire service environment, what temperature standards, ruggedness requirements are going to be there, and then programmable features, all the beeps, bonks, honks, you know, the way the buttons and knobs, when you push them, what happens when you push them. So how many of you heard of D-block? D-block has to do with this FirstNet thing. So D-block is actually the block of frequencies they were given. FirstNet was, you know, as Jonathan said, designed to be a data system, voice over broadband radio, you know, there's in there, designed in there, a voice component. But again, there's a lot of hype associated with FirstNet, and so it's not going to be the fix-all for everything. So we just need to be aware and be educated on what we're getting. If you look at the timeline, the next to the last one over to your right is on-network mission-critical voice. That's about 2018. So that's that timeline for that mission-critical voice. So what does the future hold as far as FirstNet is concerned? A lot of people are holding up a cell phone saying, hey, this is the device we're going to be carrying into a fire. Is that going to meet our needs as in the fire service? Probably not in that form factor. So these new devices and voice over LTE, the one things that we want to do with NFPA 1802 is make sure that the devices that we carry into the fire environment are going to meet these industry standards that we have set from land mobile radio. So our standard may say communications device versus land mobile radio. So with that, a couple questions.
Yep, I'm
coming. Chris Mazzone with Woodinville Firefighters, Washington. Hey, we talked about equipment, but interoperability, and this might be more of a question for you. You know, we go on fires, we need to talk to one another, but when we have MCIs or hurricanes or whatnot, we need to talk to other agencies. Is that part of the plan for the FirstNet?
It's part of the plan for FirstNet. There's components in there that will allow you to patch radio systems together, at least that voice part of it. So, and the FirstNet people, I think they have some diagrams that they can show you some of that stuff a little bit later. But that would be part of it at some point.
Okay, and was there any testing done on the ear mics and whatnot that plug into the masks for like MSA? Did those fail just as badly as the
in this study,
mics?
that study didn't address that.
Okay, thank you.
Any other questions for Mike before we move on? Then we'll have time at the end as well.
Good afternoon. My name is Derek Ward, and that's not my slide. So I'm the program manager for the Public Safety Communications Research Program in Boulder, Colorado, about 20 minutes north of here. Anybody in the audience that was able to come out on Wednesday? Fantastic. I'm glad you were able to join us. We had about a 3-hour tour and overview of the program. You're going to get a very compressed aspect of that today. From the first audience, I get to do a little bit of a lessons learned into the second audience. So hopefully, one thing is I'm going to try to slow down I'm trying to compress a lot of information into a very short period of time, but I think I'm going to try to, instead of getting into the details, I really want to leave you with some high-level takeaways. If you ever want more information, one, you can ask questions today. You can find me after this. We have a website, pscr.gov, and you can always come and visit. We're open. That's you are why we do what we do. So you want to come and visit our stuff, you can come visit our stuff anytime you want. So who are we? We fall under the Department of Commerce. Who are we not? I am not FirstNet. I do not work for FirstNet. I certainly hope to work alongside FirstNet and work with them and help make it the best system it can possibly be, but I am not FirstNet. I do serve under the Department of Commerce, and so does FirstNet. I work for NIST, the National Institute of Standards and Technology. My program, the Public Safety Communications Research Program, is a joint program within the Department of Commerce between NIST and NTIA. And it has an organization out here in Boulder called the Institute for Telecommunications Scientists. Between the two of us, we have about 40 engineers and scientists that work specifically on public safety communications issues. We've done it for over 15 years now, and all we focus on is fire, police, and EMS comms issues. That's our entire job. That's what we do. So, you're the focus. We get funding from a host of resources, Department of Homeland Security, from our own home organizations, and now we're actually starting to get money from FirstNet. They're the ones with $2 billion or $7 billion now, so we certainly, hopefully we definitely get some support from them. I'm not going to go into detail about all the various things we cover. You can read this slide. Bottom line is we cover a whole host of issues, but our main buckets in the past has been land mobile radio. Still your technology, still your mission critical voice, and our expectations are it will be your mission critical voice technology for over a decade from now. There's nothing to replace that. There's nothing that we know of or have seen that can replace that. So, and the way we operate, our sole objective in the PSCR is to be an objective technical resource for you. We're not owned by a company. We do our jobs to give you the information you need to do your job. So, bottom line is, we are the objective technical resources for you. You come to us, you ask us, you tell us what you need, and our job is to do it for you and get you the information you need. LMR, huge issue for us over the last 10 to 15 years. We've worked heavily in P25. I will go over into one of our flagship P25 programs in just a second. Obviously, though, for us, we are now moving heavily into broadband. With the deployment of a $7 billion system nationwide, we want to get this right from the outset. In P25, we spent so much time over the last decade trying to fix the things that were broken once they were deployed, whether it was interoperability issues, whether it was functional issues in the radios, whatever it was. We were working to fix those after it was already out there. With broadband and with the deployment of LTE, we have the ability and chance to do it right from the very beginning. So that's where we're putting a lot of our focus right now, is to get it right now before it gets out into your hands. Make sure when it hits the field, it does what it needs to do. And then we're also looking at emerging standard technologies that are kind of quasi fall across all areas. Video quality issues, security issues. Security is going to be huge for FirstNet. I mean, you're going to be transporting probably very, very critical medical data, license data, all kinds of things that are going to need to be secure. So that's going to be a huge, huge issue for FirstNet and LTE. And then bridging those two systems together. You've put hundreds of millions of dollars into your land mobile radio systems. They're going to be around for a decade or more, at least. And they're going to be coexisting side by side with these new broadband networks. The expectation is, if we do our jobs right, you'll be able to connect those two and leverage both together to make even a better environment for you to operate in. So our job is to figure out how can you connect those two together and leverage them both at the same time. So in the P25 world, the one thing I want to leave you with in P25 that we still are involved in and are still working in, and it's a lessons learned that public safety has to take and take with it into the broadband arena, which is when we started doing our P25 research after 9/11, we found that every radio that we tested in our laboratory, none of them fully met the standard. As we were reading the standard, testing to the standard, none of the radios fully met the P25 standard. Many public safety assumed that when they were buying a P25 radio, if it said P25 on the box, that was somehow a stamp of approval. That was somehow, that was information to you that said it had been tested and was P25 compliant. That is absolutely not the case. P25 on the box says, as a manufacturer, that is my marketing logo to state that I believe I have implemented the P25 standard in a way that I feel is right, and I'm giving it to you. So it does not show that it's been tested in an objective or independent laboratory, and it does not mean that it meets the P25 standard. It means the manufacturer believes it does. So what we did is we began immediately working with the Department of Homeland Security to create a test program that would be held in objective laboratories that we assessed, so that manufacturers would take their P25 radios to those labs, have them tested, and would have to post that information publicly. We have them post, that information is public. It is on the DHS website, rkb.us. You can get 95% of the manufacturers are all planned. You can get their information, their test data, pass, fail, across a whole host of issues. The gentleman in the back asked about interoperability. A large focus of those tests are interoperability tests. There's matrix against all of the subscriber units from the various manufacturers tested against each other. So you can see subscriber unit 1 worked against subscriber unit 2 on this column. And there's whole matrix information. All these tests were performed in assessed laboratories that have proven that they can run the tests, they know how to run the tests. So I encourage you to take advantage of that. What public safety has to learn from that is you can't come in 20 years after the fact and create a program like that and expect everything to be okay. You got to do that from the beginning. That should have been done from the very beginning. The minute P25 was developed, it should have also developed a test program to ensure products met the P25 standard. Instead, we came in way too late, and so it's been an important add to P25, but it would be much more powerful to do it from the beginning, and absolutely FirstNet has the intention of having a test program to ensure that products meet its requirements. Every discussion we've had with them, they've made that very clear. And we hopefully are going to help them with that. So this just shows you exactly where the D block or where the public safety broadband spectrum is. It's 20 megahertz of spectrum provided to public safety and held. FirstNet is the licensee, the nationwide licensee for that spectrum. The columns in blue are the FirstNet spectrum. 10 megahertz uplink, 10 megahertz downlink. Right next to the FirstNet spectrum is Verizon, LTE. So anybody using Verizon here in LTE, that's where theirs is located. Right next to Verizon is AT&T. FirstNet, Verizon, AT&T, all deploying LTE technology, as well as the vast majority of communications carriers around the world. Interestingly enough for FirstNet, though, is to the right of the FirstNet bands is public safety narrowband at 700. Right next, directly adjacent to the FirstNet broadband spectrum is public safety narrowband. So one of the things we originally began to have a concern about is there any potential of interference between public safety broadband and public safety narrowband, because they could be coexisting directly next to each other. And in fact, here in Colorado, we have a public safety narrowband statewide 700 system. So as we were setting up our lab, we had to worry about that. We didn't want to screw up public safety operations. So we immediately did testing on that, and we actually found that we don't have many concerns at all about the interference either from narrowband to broadband or broadband to narrowband, and so that's a good outcome. So what do we work on? To get the technology correct, and we are technologists, that's what we focus on, but to get it correct, you have to address a whole host of things all at the same time. And so I want to give you a little bit of a understanding of the complexity of what you have to address to get this thing right so that it works when it gets in your hands. Bottom line is, and here at the PSCR, this is what we start with and we end with, is your requirements. What is it you need the technology to do? What does it have to do for you to be successful in your job? That is one of the biggest gaps we always have when we're trying to figure out what technology to apply to public safety is, where are the requirements? How do you get them? I can't just go talk to one city, because I swear, you go talk to one city, you get one set of requirements. You go talk to another city, you get a totally different set of requirements. So somehow you've got to gather these up and have a collective view of requirements that you can use. So what we do is we utilize a group called the National Public Safety Telecommunications Council. And it is an association of public safety associations. So there's a host of associations on there representing public safety from EMS, fire, and police. We have worked with them for over 10 years to develop requirements. We are their technical experts in running requirements programs. So we've developed a statement of requirements in 2004, and over the last 6 years we've been doing specific public safety broadband requirements work. And that is ongoing. If I could leave you with anything, I would say if there was an opportunity for you to get involved in that, and most of these are all done by conference call. It's all done by phone call. If you can get involved, that is the most important thing we need, is a clear understanding of the requirements of public safety so that we can then take those requirements into the next phase of what you have to do, which is then standardize them. Or else every manufacturer would just take those requirements and start implementing them differently, which says you absolutely no good when you deploy that and expect interoperability. So you have to standardize those requirements. So that's what we do with them. But we can't do it well if we don't have good requirements. And good requirements comes from participation from public safety. So to give you an idea of some of the types of things that the requirements we're working on and why they would be very important for you is we've heard today about mission critical voice. That was not expected or thought of when they were developing LTE. LTE was developed globally, internationally, as a commercial standard. It was made for you and I driving down the road, talking to mom, downloading YouTube videos, watching Netflix, and it's an amazing technology. I mean, in my home, I have a wired modem into my home where I get about 20 megabits per second, right? And that was fast in my house. We're seeing 35 to 40 megabits wirelessly in our LTE network. So it's totally changing what you can do on your mobile device, and you're seeing speeds that outpace what you even get in your house wired. So it is amazing. But it wasn't made for public safety. It was made for us as consumers. So one of our jobs is to take your requirements into those international standards bodies and drive those public safety needs into the commercial technology. Mission critical voice is going to be one of those. The mission critical voice is complex. It is not just the ability to pick up your phone and talk. It's the ability to have direct mode communications off network. It's the ability to have group communications. It's the ability to do push to talk. Those things, none of those things were considered in LTE when it was developed. Those things are now things we're pushing into the standard. So, but first we have to understand, what does mission critical voice mean to public safety? So that was a working group within NIPSTIC that helped do that. Local control. What does it mean for you now? Let's say there's a nationwide broadband network, and it's an LTE network like Verizon and AT&T. You're probably not going to go to your local tower and start messing with the box anymore like you did with Lambo radio. But you're still going to want that local control in the network. So how do you get that? What is it? It's probably some interface on a computer. But how can you say, today Captain so-and-so is priority 1 on the system and somebody else is priority 2, but tomorrow, given the incident, you may want to switch that. And how do you get into that system and switch it? That's all about local control, and what does that mean to public safety? Priority and quality of service. That is a key feature in LTE for public safety. It is in the standard, it is not deployed in commercial services. Commercial services, you all know it because you all use it, it's best effort. If you get on the network and you get that YouTube or Netflix stream and it's good for you. If your next door neighbor's already got it and now you've only got 1 megabit per second and it stinks and it's all pixelized, well, too bad. You have to wait for him to get off. Priority and quality service is built into the standard. We've never seen it. We don't have any equipment in our labs that do it, but it will be key to be able, for public safety, to be able to say, these people have these priority, and given the situation, we will kick priority 5 off to make sure priority 1 has all the bandwidth they need to get everything they need to have done. We need to see that, but we also need to know what it means to you. So we're taking all of those issues into the standards bodies internationally. Proximity, or talk-around mode, or direct mode, group efficiency, push to talk. Those are all currently things that we are driving into the international standards bodies, into commercial equipment. That's the kind of stuff that's going to make LTE really useful to you at the end of the day. Now, everybody in my laboratory that works with me, we are all show-me people. We don't care that it's on a piece of paper in a standard. Until we actually see it and deploy it ourselves and test it, that's the only time we're going to look at you and say, yeah, this actually works. So we built a an LTE 700 megahertz test network in Boulder. It's made up of, it's probably one of the most complex and diverse LTE networks in the world now, made up of a host of different, almost every LTE manufacturer is deployed in our network. And what we do is we run tests. We've done interoperability testing to ensure we wouldn't run into the same issues that we have in P25 where you can't mix and match vendors, especially across infrastructure. But now we're going to be using that network to test mission critical voice, test priority access, quality of service. So that's our show, that's where we say, show me the money. Okay, you say you got all this good stuff, now you got to prove it. You take to our labs and we prove it. And we do it hand in hand with you. The things that you're going to hear from Anna, which is about audio quality, the key to understand how we do our audio quality work, our video quality work, we bring in hundreds of practitioners. You guys walk through our laboratories. We torture you. We sit you in soundproof chambers for 3 to 4 hours at a time, and you guys sit there and you say, oh, I heard this word. I saw a gun in that guy's hand. Now I didn't. I saw a cup. You drive our program. So anybody interested in being part of that after this, drop me your card. We're always looking for additional people to stick in soundproof chambers, but it always gets you to Boulder, Colorado, so it's not a bad deal. These are just pictures of our sites. We also have a cell on wheels that has every manufacturer's base station that we have. We can drive it all around the Boulder area. That's just a picture of some LTE base stations that would be at the base of a tower, deployed. This was one of our sites that was actually deployed right next to the 700 narrowband to make sure there wasn't interference. So bottom line is, we're driven by your needs, but we need your help. I hope you guys get involved, because we can't do what we need to do unless we hear what you need to do first. So with that, I'm going to hand it over to Anna, and she's going to talk about the audio quality experience and the work that we've done on digital audio quality in the fireground noise situations. And hopefully you guys will get some interest out of that. So.
All right, we have a couple of minutes to just entertain a couple of questions for Derek while he's right here. Any questions for Derek? Yes.
And the 700 megahertz, what's the difference? I mean, clearly, Phoenix had 800 and it failed. If they have to bring 2 radios with them, why is 700 going to be any different?
So it's not the only thing about the spectrum. So 700, 800, just about the spectrum allocation, right? The important thing about the allocation for the FirstNet network, spectrum-wise, is that it's one contiguous block of spectrum. So now you're not dealing with public safety's dealt with for decades, which is blocks of spectrum all up and down the spectrum from 400 all the way to 800. And you have to have these radios now that have just only recently come out that can actually talk across all that. The important thing out of 700 that came to public safety is one contiguous block of spectrum, and everything will be deployed in that spectrum. What's different is the technology. P25 land mobile radio is a totally different technology than LTE. LTE is all internet-based IP technology. It's the same kind of stuff. It's cellular technology, where land mobile radio is land mobile radio, a totally separate type of technology. So it's not about where the spectrum is. It's not about 700 versus 800. It's about a contiguous block of spectrum in 700 to deploy broadband LTE technology.
All right. Secondly, you mentioned that it'll be run with cell sites.
Yes.
I don't know if you realize, but we had an incident in April in Boston, and part of what the feds did was they shut all the cell sites down.
Yes. So
that would be devastating if we were on cell sites.
Right. So, and I'm not saying yes to that. I know that happened. I'm saying yes. I understand your question. The issue with this is one reason FirstNet was created. Public safety, a lot of public safety use. How many people in the room through work have a cell phone for your use? So how many people use broadband smartphones for your work? Okay, so a number of people use them. The problem is, in Boston, in a bombing event, anytime there's a major event, earthquake in DC, you're using the same system that I'm using to call home to mom to tell her I'm alive, right? And that network gets saturated immediately because you've got hundreds of thousands of users in a very small geographic area all calling, congesting the system, shutting it down, right? FirstNet and this spectrum allocation was created because this is now simply your network. There's nobody else on it. So, and if I'm a cell phone, if I have my cell phone, the problem is I know how to transmit on that spectrum to do what they were trying to, somebody might try to stop to do in the Boston situation. In this case, this is a dedicated public safety frequency that is made for public safety to operate on. Nobody can kick you off. You've got priority access on it. It's not going to be me calling my mom. I won't be calling on your system to do that. And if I did, I wouldn't have the priority to be able to.
It's not shared with any commercial cell phone?
It could be. The legislation allows it, but only.
Well, there's the problem.
Only, but public safety has priority access on that system.
Yeah, but if they shut it down, they shut it down. I know we go around and around, but I'm just curious.
I can just say that it is your dedicated spectrum that is, and you will have priority on it, and that is the intention.
We'll shift over to Anna.
Yep.
Guess we lost the clip on here.
Just set it up.
Okay. Okay. So as Derek said, my name is Anna Paulson, and I'm an engineer at PSCR, and I'm the audio quality project lead. And today I'm going to talk about some of the recent studies that we've completed, well, recent, all the way back to 2008 until now. Since that time, we've published basically 3 kind of landmark studies, and I'm going to quickly go through some of the results of those. And if you guys have any questions, I know it's going to be fast, but please ask those at the end. And also kind of at the end of my presentation, you'll see a slide that where I'm kind of asking for the problems that you've had out in the field that are related to audio quality. I come to these things as a researcher because I care when you have problems. And unless I kind of hear about those problems, it's hard for me to kind of investigate those and maybe come up with a solution. So while I'm talking, please try to think of the problems you've had that are related to audio quality, and let's talk about those kind of at the end. So PSCR started getting into the audio quality kind of game sort of as a result of the FCC's narrow banding order. As many of you know, FCC mandated that land mobile radios had to go from 25 kilohertz. Eventually they wanted to go down to 6.25 kilohertz, but they kind of ended up at 12.5 kilohertz analog. And as a way to kind of go down to 6.25, they started introducing digital radios. And so at one point around 2006 or prior to that, manufacturers started releasing these radios to the public or to people in the fire service and public safety. And so it was 12.5 kilohertz digital radio. And we started to actually hear problems. Basically, people from the fire service were saying, hey, this new digital radio, it works fine if I'm in a quiet, closed room, but it starts to have a lot of problems when I'm using a chainsaw or I'm riding in the back of a fire truck. And I'll kind of go into some of those problems later. But so based on that input, we did a study in 2008 and looked at how the kind of that current state of radios, so we had some 25 kilohertz analog radios and some 12.5 kilohertz digital radios sort of performed in high noise and no noise, situations. So this slide actually has some examples of the sound samples that we used from that study. And I'm going to play these for you. And the first one is an analog radio in the presence of no background noise. And throughout all these slides, it's the same voice clip. They're just kind of treated differently.
Clear on rotating the teams. Clear on team 1 has par.
Okay, so that was full bandwidth analog radio. Pretty easy to understand what he's saying. Here's what the same thing sounds like with the P25 radio.
Clear on rotating the teams. Clear on team 1 has par.
It may be a little bit difficult to hear it in here, but I can hear that that's actually a digital radio. You can hear tiny digital artifacts in it, but it's still very what we call intelligible. You're easy to understand the words and be able to reproduce the words that he's actually saying. So we start getting into the problems, the high noise problems. Here's what that analog radio sounds like with a low air alarm.
Clear on rotating the teams. Clear on team 1 has par.
So difficult to understand, but you can still kind of make out what he's saying. Here's where we really started to see the problems. This is the P25, the digital 12.5 kilohertz radio in the presence, with that same voice sample, in the presence of a low air alarm.
Clear on rotating the teams. Clear on team 1 has par.
Okay, so I don't know about you guys, but I have no idea what he's saying. And that's really kind of sums up the problems that we were getting from the field, or the reports that we were getting back from the field. So as I said, we conducted this study, and the way we kind of do this is we have what's called a modified rhyme test. We play like a series of rhyming words through a head and torso simulator in a quiet room, and then that goes through a land mobile radio, and it's transmitted over wire, so we can take the air interface variable kind of out of the equation. That goes into a loud room where we play, things like the low air alarm. And then we take those voice samples, we chop them up, and then we play them for, as Derek was saying, our subjective test subjects, the people that actually come in and sit in the rooms. And so we'll play them a voice sample and then ask them to select that word from a group of rhyming words that are on a computer. So that's kind of what this slide is like, and I'll play for you some of these voice samples. So the first one is The Mask in 2008, no background noise, and the 59%, that's the intelligibility. Basically, 59%, 59 people out of 100 were able to understand what she was saying. So I'll go ahead and play that.
Please select the word went. Please select the word sent.
She's actually saying, please select the word went, please select the word sent. So that's what we would play to a test subject, and they would try to correctly identify that word. So here's what it sounds like with the pass alarm in that same kind of voice sample.
Please select the word went. Please select the word sent.
So it's kind of easy to understand now that I've already told you it, but if you listen to that for the first time, it's very difficult to understand because the way these radios work, they take the entire noise that they're hearing and combine it together and try to chop that into a digital signal. So it's, when they're in the presence of noise, difficult to understand. So after we released this study, there were a couple of changes that were made, caused quite a furor in the industry. One, we actually worked with people in the fire service and public safety to come up with some best practices. And those are things that are as simple as if you're wearing a SCBA, a kind of scuba system, to move the microphone on the radio closer to the voice port. Another one would be to actually wear it on your lapel, so it's closer to where you're actually trying to talk. So some of those best practices, one of these last slides is an example of what it sounds like with some of those best practices.
Please select the word went. Please select the word sent.
So that's a comparison to the mask in 2008. Basically, just based on that best practice, something as simple as moving the mic closer to your mouth, it went from 59% understanding kind of rate to 69%, which is good. Every little bit helps. And finally, the real kind of big one was the pass alarm with the updated vocoder. As I said, we worked with both firefighters and the industry, and one of the results that came from the industry is they actually changed the way their vocoders are designed and manufacturers, and it led to a pretty big improvement. So hopefully you can hear that.
Please select the word went. Please select the word sent.
So in that case, still annoying, still hard to hear, but you can actually understand what she's saying because it sounds like the noise is sort of over here and then what the actual speech is over here. It's a little bit easier to make out. And the numbers kind of bear that out. It went from 21% intelligibility to 50%. So the two studies that we've done this year, they focused mainly on VoLTE, which a lot of people have talked about. And there are two kind of vocoders that we are looking at. One would be the multi-band excitation vocoder, and that would be the vocoder. And when I say vocoder, that's what simply turns the the analog sound waves that come out of your mouth into a digital signal. So we looked at the MBE vocoder, and that is the vocoder that they use in a P25 radio. We also looked at the AMR vocoder, and that is the vocoder that they use in like a commercial cell phone and what they would use in like an LTE device. So the first study that I'm going to talk about, it looked at the interactions between those two vocoders. And by interactions, I mean in a kind of real world scenario. Say I'm a firefighter out in the field, and I need to call my chief, who is at home on her cell phone. So that would be from a P25 system, somehow gets into the commercial cellular network, and goes to the chief. And it also looked at going from the chief to me. So we call that a homogeneous network. It's two networks that kind of work together but are made up of different parts. So this first graph just kind of shows you, this is similar to the next graph that I'm going to show. It shows on the left side on the vertical axis what's called the mean opinion score. And that's how we rate intelligibility. And you can see generally it goes from 1 to 5, but in this case we're kind of centered around the 3 to 4 kind of region. And just to give you some idea, 3 to 4 is pretty good. 3 is considered fair, 4 is better, 5 is good. So there's MBE at, and also shows there's a couple of different bit rates. MBE, which is the P25 vocoder, that only has 2 bit rates, half and full rate. And the AMR vocoder has a lot of different ones. And there are different flavors of AMR. There's AMR wideband. But so looking at this graph, it looks like MBE and AMR generally, or MBE performs less well than AMR. And that's sort of true, but when you think about it, MBE was actually designed for a specific purpose, to be used in kind of a low or reduced bandwidth situation. AMR is used for a bunch of different situations. So this is really kind of apples to oranges. It's a little bit misleading, but it is used to show, like, give you a baseline of how these actually perform at the different bit rates. So the real kind of meat of the study is in these two graphs. The horizontal line that goes on the top of them is how the MBE vocoder performs at full rate and half rate. And you can see the graphs that are underneath that. That shows the interaction between from AMR to MBE, or from commercial cell phone to a P25 radio, and vice versa. And it's pretty easy to see in both cases. When you connect those two systems together and talk across them, they don't perform as well as either full rate or half rate MBE. So our main kind of takeaway from that was that, you know, technology changes all the time. There's always going to be a bigger, better vocoder. But when you plug these two systems, or when you plug systems together, there are going to be kind of unforeseen consequences. And system designers and the people that use this really need to be kind of cognizant of this and look out for it, which I know is tough to do. The next study that we did, and I know this is kind of an eye chart, but bear with me. The next study we did was we kind of took this new AMR vocoder knowledge and circled that back to the original 2008 study. So we wanted to look at how analog and the P25 and AMR vocoders performed in low noise and high noise situations. And this actually kind of summarizes the results better, but in general, and you're free to look at this and we can talk more about it later, but in general, the AMR vocoder, which would be the FirstNet LTE vocoder, it performs as well as or better than analog in many cases. And in almost all cases, it performs better than P25. So our main kind of takeaway from this is that when you guys eventually get to FirstNet, we believe that, based on the research that we've done, your audio quality experience will be as good as or better than what you're experiencing now, which is good. So a lot of people have talked about VoLTE, voice over long-term evolution. You know, the real kind of important thing to me is that the LTE network, it's all IP. So voice is data, and everything is an application. You know, you have a video, your telephony, your push-to-talk. Those are all just kind of different flavors of applications, and they kind of operate on the same kind of set of data. So VoLTE uses something called IP multimedia subsystem for the management, services management, and it uses SIP or session initiation protocol for the signaling. And as Jonathan and Derek kind of pointed out before, it's not mission critical voice. It does not support that. There are some of the parameters. I believe one day it's probably capable of that, but in its current configuration, it does not support mission critical voice. So this next chart is from a paper that I wrote to give you a kind of example of all the different parameters that lead to a well-working kind of LTE system. And if you look at the bottom, the stuff I'm really kind of concerned about is the voice. It says to use, if you've set all these other parameters correctly, then you should use like 12.2 kilobits per second, G.722, which is AMR wideband. And the kind of takeaway from this is that, you know, wireless communications are so complex. And like, if you don't have all these parameters just right, you're not going to be able to talk. You're not going to have in-building penetration. Your voice quality is going to suffer. So all these are really important, and I understand that these parameters and knowledge of these parameters are probably way beyond the scope of the average user. Maybe even beyond the scope of, you know, the technicians that you have. So it's really important that you guys kind of get good advice on these sorts of things. So now is question time. We can kind of talk about that. What sort of audio quality problems have you had that you'd like to talk about right now? Anyone? Yes.
The digital echo with the delay. There's a room full of firefighters staying in the room. And the digital delay, the echo, is a huge problem for us.
Okay. And I'm not going to really tell you how to solve those now. I'm just kind of collecting these, but that could easily be a configuration issue. But I understand it's kind of hard when you have a bunch of people in a closed space. That microphone is picking up on everybody else in the room, you know. And you see that at nightclubs when you have kind of two microphones going together. But thank you, that's a good comment. Anyone else? Okay. Look. Yeah.
How about the effect of a repeater on a digital signal? Is it any different than if it was land-based or mobile?
It's kind of different. I'm talking about the audio quality portion. That would be more the air interface.
Yeah, I see.
But, I mean, it does, you know, if you don't have good signal strength, then you can't do anything.
Right.
So that is important, but it's kind of hard to get into just from up here. But
Well, I have other questions, but I guess it doesn't. I mean, why are we changing the system? If it's new technology, it's better technology, but it doesn't seem to work. We have to interpret the digital signal to make it like it was an analog. It doesn't really make any sense. You know?
right. Well,
Just because it's new technology and it's up and coming, we can't maintain the old technology, even though the old technology was better. We have to go to the new technology.
right. I think, I mean, Derek can kind of talk to this more, but I think the idea was to give users a lot more bandwidth. So even though it's kind of data, when you have a lot more bandwidth, you can simulate or emulate a 25 kilohertz analog signal, you know, because you have that sort of bandwidth. That's hard to do when you have a bandwidth constrained digital radio. But, you know, there are so many changes, it's not even, almost not worth going into, but it is better.
It really comes down to there are so many of us that want to talk at the same time. We can't use the analog systems to make that happen. Right.
Right.
Right. So we're trying to get to that point where all of us can talk to each other at the right time with this much space.
Will we be able to do that?
Cross your fingers. It all depends on if they build it right in the first place, right? Crossing our fingers. All right, are you all set? Any other questions for Anna? Yes.
My question is, when you're in with your crew and you go to key your mic, all we get is feedback through all the radios.
Okay.
So you'll be with your crew and you got to tell everybody, turn your radios down because I can't transmit it, because when you key the mic, all it does is sounds like squelch.
Right. Yeah, again, it's similar to what he said. That could be a configuration issue, but it's hard when you have an open mic in a room full of other mics. They're going to all kind of pick on that and all feed back into each other.
This might be for Derek, I don't know, or whoever. With this new system coming in down the road, will it enable radios to be able to transmit out of a building such as, for example, for us, we have a hospital, and if you go in the middle of this hospital or go to the basement, you can't transmit out without changing to a special backup channel, and that just goes radio to radio, and nobody else can hear it.
Right.
And with this new system, will you be able to be somewhere and communicate?
Yes, but the you know, the way the LTE system is designed, you don't have infinite reach. So you're still going to have repeaters. People are, you know, when you're in building, you're going to have to use things like small cells. There's a lot of kind of, just LTE as itself does not offer more reach necessarily than, you know, the other kind of radio systems that we're using. There are things that you're going to have to do to improve that, but we're aware of that.
Right, and a lot of this is system design and designing it right to begin with. And when the brothers suggest that when this new system comes, we're hoping that the testing and the engineers are going to have that sorted out before they come sell you the subscription to this new system. I would be more concerned about making sure your radio techs maintain your 800 megahertz systems or your 700 megahertz systems that you have now, working through the high efficiency glass that's in those buildings. The place where I came from, they've had to add a repeater specifically at the hospital to solve that problem. Okay, so they turn that on. When the ambulance gets there, they go to channel 10, and that's how they talk through there. So it's a system design enhancement.
It is.
All right, I think we have one more question, and we need to move to Kevin.
Yeah, and I appreciate the work you're doing. Under the new SCBA standard, they've standardized the pass device. It's kind of a bird chirp. Have you studied that any? Is that going to make it? Is that going to make it? Well, it's all the air packs will have a standardized chirp. So will that make it easier since it's just basically one sound instead of several different? Or
we had a similar question the other day on the tours, and I think what you're kind of getting at is if you kind of know what the high note is going to sound like, can you make a filter that would filter all that out in the radio? And the answer is you can. It's easy to do. But the direction we're kind of moving towards is we want something that is more general purpose, more utilitarian. And so we probably wouldn't do things like that. Instead, we would try to work with the manufacturers and have them generally improve the vocoder without having to do such a niche kind of market solution for that. Does that answer your question? Okay. Thanks.
All right, well, Kevin gets adjusted up front. I'll just throw what I interjected in the last session. A show of hands. How many of you have radio divisions that can talk the talk at the level that Derek and Anna work at? Vocoders, digital bit rates. I know Boston does because I know who your guy is, and I know he can talk this. How many of you have radio techs that can take it out of the box, screw it in, turn it on, and instruct you how to use it? That's your guy? Okay, we'll talk to you later. It's important, and it really is. For the speccing these things out, whatever new device, forget the FirstNet piece, just the next iteration of radios that you're going to go to, you need to be at the table and say it needs to do this, which is talk from the basement when I'm on fire, right? It needs to have automatic cutovers or backups to analogs. It should comply with the standard. All of those things, you need to be part of that. Your techs need to be understanding the digital quality issues. Can't just be that guy on light duty that knows how to put radios in. That day is done, okay? I was one of those guys. So, you ready, Kevin? All right, you're mic'd up, good.
Great, thanks. You've heard all the smart people talk, now it's my turn. My name is Kevin O'Connor. I'm the Assistant General President for Governmental and Public Policy. And essentially what that means is I try to take presentations like this and technology and different information is developed by our staff, our smart people, distill it into normal people speak and try to lobby on your behalf to make sure that there's an understanding of our issues and generate some synergy on Capitol Hill and in state capitals to make sure that we get what we really want and what we really need. The General President thought that it was important as part of this presentation basically to conclude with, if you will, almost something just to provoke questions and thought. There is a train coming down the tracks of all of us in terms of communications because of some legislation that was passed and because of changes in technology that's going to impact your department, your city budget, your union, your members, and the finances of your members. And part of what I'm here to do today is just try to put that out there, let you understand it a little bit. I'm not here to talk about the specificity of talking through a face piece or things of that nature. I'm looking much more on the macro level to make sure that as some of these issues come forward to you, that one, you're aware they're out there, and two, you know the right questions to ask. Primarily, my presentation is going to be about the whole FirstNet piece, what was developed as a part of the Middle Class Tax Relief Act in 2012, some of the unintended consequences, and some of the things that you need to be very prepared for. I am not here to promote FirstNet, and I'm not here to castigate FirstNet. There are those that think FirstNet's a promised land. There are others that call it toys for chiefs. It's something that, frankly, you're going to have to make those decisions yourself. What I'd like to do is try to put this in a context, primarily legislatively, but also a little historically, of how we got to this point, a short little bit of history, and then talk about the FirstNet project in general, move a little bit to T-band, and then talk about the conclusions. Why are we here? For years, obviously, anybody in the fire service recognized we've had communications issues. As previous presenters have talked, we were all over the spectrum. You hear the horror stories, obviously, from 9/11, from Hurricane Katrina. You know, I remember when I was on the job and we put in our truncated system in 1987, firefighters in Philadelphia were getting our transmissions from the Baltimore area. There were clearly problems. It's something that needed to be addressed. As a matter of fact, one of the major recommendations of the 9/11 Commission was that the issue of interoperability be addressed. So all of this started for the right reasons. Where were we? Other presenters have talked about, you know, LMR, land mobile radios. We know they work. Yeah, we've had some issues with them, but by and large, they provide mission critical voice, which in the IAFF's opinion is the most important aspect of communications. Jonathan said it very well. When you're in the basement and fire's all around you and you need to get out, you need to be able to press the button. First and foremost, that's the most important thing. But we all recognize that LMRs aren't very good for data transmission. So when we actually got to the D-block issue, and there were a lot of more grandiose ideas and schemes that were around for a number of years, some of it building out networks almost comparable to AT&T or Verizon, spending a heck of a lot of money. But as in everything else in Washington, D.C., a price tag really dims what you're able to accomplish. So ultimately, the IAFC, the IAFF, a lot of other stakeholders really were promoting that we needed to move forward. We really needed to get some type of contiguous real estate, broadband, that really allowed us to grow into the future. It's important to note that the first aspect when D-Block was first mentioned is it was a data network, an interoperable network for data, not for voice communication. That came a little bit later. I'm not going to delve into the specifics of that. We know the limitations. One of the slides that was up there saying that we're supposed to have mission critical voice in 2018. I certainly would not count on that. That's not something that I think anybody can guarantee. This system was supposed to augment our existing, whether you're on T-band, whether you're on other frequencies, this was supposed to be a data system. So with that as a background, the IAFF's position on Capitol Hill consistently has been nothing can interfere with mission critical voice communications. It was a very long process to get to the point where D-Block was actually allotted to the Fire and Emergency Service. It was done in February 2012 as part of the Middle Class Tax Act, Public Law 112-96. Now what did this actually do? First, it allocated that spectrum, the D-Block spectrum in the 700 band, to public safety for our use. Probably had a value, if you listen to cost estimates, anywhere about between $3 and $5 billion, just the spectrum real estate. The government also put forth $7 billion for FirstNet to be able to build out this network. Now I'm going to talk about some of the problems of that a little bit later. It also established the FirstNet Board, which is a quasi-federal government entity under Commerce that holds a license and actually is charged with building these things out. One of the questions or one of the statements that Ralph made, and he's absolutely right, when he was talking about it is, will commercial users be able to be on the system? That's a decision that FirstNet is going to make. A lot of us feel very strongly about that, that ultimately if that is to occur, how do we know we will have priority? So FirstNet is vested with a tremendous amount of power and a tremendous amount of responsibility, and that's something that as first responders we all need to understand and be very vigilant. The final concept or the final aspect of the law was, as has been mentioned, we have 11 major metropolitan areas, 2 of them I see here, Boston and Washington, D.C., that are on T-band. And that is supposed to be relinquished back for auction to help pay for some of this stuff and to pay for the transition of those cities off T-band, beginning in 2021 and ending in 2023. That is a real problem, and I'm going to talk about that a little bit further down. So again, as we move forward, we want to make sure that we protect mission critical voice. So now we're here. Is FirstNet a good thing or a bad thing? Well, it could be either. You could be from a jurisdiction that you need that type of data transmission, you need that type of technology, you're not happy with what you have now, you've got a great LMR system, a great voice system, and this could augment that very, very well. You could be in a jurisdiction where, quite frankly, it doesn't work. There are a lot of issues that need to be resolved. So the goal of FirstNet, frankly, of creating a national interoperable system, it's a very laudable goal. But as you often heard, the devil's in the details. And I'm probably going to repeat this line a couple times between now and when I conclude. But really, you have to be aware of unintended consequences. That really, I think, is the takeaway here. It's a good idea. There's going to be growing pains, but you have to be aware of some of the unintended consequences. Now, there's 3 very major problems here. Problem number 1 is money. I mentioned the federal government only allocated $7 billion to this. Sounds like a lot of money. But when you do a comparison, and I'm going to quote the chairman of the FirstNet board, the chairman of the board that is supposed to implement all this stuff, spend the money wisely and make sure we have a system that works. He actually made an analogy that when AT&T and Verizon both started their national systems, they each spent in excess of $50 billion. And he noted that he was only given 7. And our system's going to be a hell of a lot more probably expensive in a lot of ways to build because we're going to need additional towers, we're going to need to do a lot of the things to make sure that the system works because we can't afford to fail. And we were only given $7 billion. His response was, how in the world can we do that with that amount of money? And this is a chairman of the FirstNet board who's charged with doing that. So we have to be very, very careful. We all hope this works. We think it's a great idea to be able to transmit data, whether it's telemetry information, whether it's information on chemicals, whatever it is. It's a great idea, but again, not at the expense of what we currently have. The second issue, money. Money again, in this case money, because when this is done, this is going to be a cash cow for one hell of a lot of vendors. Whether ultimately it's Verizon that's allowed to do this, AT&T or someone else, they're going to make a hell of a lot of money. Beyond those 2 type of companies, the people that are going to make money are the people who sell the radios, the trinkets, the construction that puts these systems together. This is going to be a massively expensive project. Don't think that the $7 billion is going to be enough to do this if they legitimately want to do that effectively. So the pressure that that puts is, we've talked about mission critical voice, that it's supposed to be done in 2018, but maybe it really won't be. These folks want to move ahead. Their attitude is damn the torpedoes, full speed ahead, because at the end of the day, they're looking at making a lot of coin. So we need to be aware that that dynamic is out there. The third issue, once again, money. But in this case, it's your money. It's the money of your jurisdiction, your fire department, and your members. Why do I say that? Remember, originally, this was meant only for data. It was not mentioned for voice. The word hype has been used several times with respect to FirstNet. A lot of people don't understand that. A lot of city managers don't understand that right now, All that provides is data. So you've got people coming around talking about this as if it's nirvana, as if this will answer all of our communication problems. It will not. So you may be in a position where you have this bucket of money for communications. Do you use that money to support your existing voice system, your legacy system, to make sure that when you're on the fire ground, you're able to communicate? Or do you use it for FirstNet? Again, those are decisions that have to be made. As you extrapolate that even further, let's assume that this becomes a more expensive endeavor. It's something that can hit your bottom line in terms of safety. Is this something that a jurisdiction is going to say, you know what, we have to segue into the FirstNet program, so maybe we're going to have to shut down a station. Or maybe it just won't even affect those type of budgets. It may say, we can't afford a pay raise next year. So the macroeconomics of this are going to filter down, and it's going to hit your local and its members in their pocket. I don't say this as to be threatening, but it's something that you need to be aware of. The number of people that did not raise their hand on understanding or recognizing what FirstNet is, this is something you have to know and you have to educate your employer about as well. It's something that really can be a problem. So from our end, again, I'm not here to criticize or to promote FirstNet. You really need to evaluate the issues, and when you're dealing with policymakers and you're dealing with vendors coming in, you need to ask the right questions. You need to make sure that the system works well with your current voice system. You need to understand how much it's going to cost. You need to look at alternatives. Our staff has developed a great cheat sheet that talks about FirstNet, whether you're obligated to go into it, which you're not. It talks about a lot of the various contingencies. It's a really good cheat sheet, and I'd really recommend that you not just read it yourself, but share it with the different folks in your department. Just don't buy things. Don't buy the trinkets. Make sure it's something that, you know, frankly, you really need. I'll conclude on this segment of it before I talk a little bit on T-band by saying prioritization. From a safety perspective, it is our view that you have to protect your mission-critical voice. That's your #1 priority. Let me move a little bit on to T-band. This is the unintended consequence. There was a great report. Derek referenced NIPSTIC, organization of various first response organizations that published things. They had a great report when the T-band cities came out March 15th of this year, and it really went into depth about the cost. It's projected that it's going to cost probably about $6 billion to transfer all these cities off. My view is money's really not the big issue. The big issue for a lot of these jurisdictions, money's always an issue, but the big issue for a lot of these jurisdictions, Boston included, is everybody that's taken a look at it doesn't think there's available space for them to segue to, that they can't just say, I'm vacating T-band and then I'm moving to another frequency. It just simply doesn't exist in a lot of these cities. At a recent FirstNet board meeting, Jonathan referenced it. I don't know if anybody's in here from LA County. I don't see Gelati. But the LA County did a presentation to the FirstNet board. They're one of the T-band cities, and they said just that. They said there is not a place for us to transition off of T-band. Huge issue. It's important to understand how it got into legislation. Nobody ever really thought that, you know, T-band was on the table. You've all heard of new math, you know, Bush's voodoo economics. This is congressional math. Somebody got the bright idea that to make the numbers work at the end of the day, that there had to be a trade-off. And they said, okay, we've got this T-band area, this T-band real estate. We think that at the end of the day, it might bring $6, $7 billion in auction. I could talk about that. That probably would not occur for a number of reasons. Televisions are using some of that spectrum space now, so it's not clean spectrum. There's a lot of problems with this. The point is, I mentioned when I began, you're supposed to be off a frequency by 2023. This is going to be our major legislative endeavor. We have to make sure that for those cities where this is working, that they do not incur the disruption in service, the threat to safety, and most importantly, well, not most importantly, as importantly, the cost of doing this. So we're going to be working with the mayors of those cities. We've reached out to the League of Cities already, and this is something that the challenge that we face is everybody that's been in local government, you know, you make your projections and your plannings long range. You're doing a capital budget, you do it for 10 years. That's not how Congress works. Congress really doesn't work at all right now, but they certainly don't work looking 10 years in the future. So the fact that this transition isn't supposed to take place for another 8 years, For them, it might as well not be 2022, it might as well be 3022. So trying to make sure that we focus the attention on that they have to solve this problem, they have to make sure we have some assurances, but it's a very major issue. Let me conclude by saying, you know, I don't know whether this is Toys for Chiefs or the Promised Land. It's got some growing pains, it's got some problems, very well intentioned, a lot of potential. Ultimately, I agree with Anna, I think the technology will ultimately be there for this, but whether the technology's there in 10 years or 15 years, in the interim, we can't lose what we have, and we can't go off the air and lose our ability to communicate. Our aspect is going to continue to be do no harm, protecting the legacy systems to make sure that we currently are able to do that, and at the end of the day, try to move forward that way. I'll conclude my comment, and this is Kevin's observation on FirstNet, no one else's. Most people in here understand our pension system. Most people have a 457 defined contribution plan. Everybody understands that 457, it's a great deal. It's a great augmentation to your retirement, but that's what it is. It's a supplement. Your real retirement is your defined benefit plan, your pension plan. This is the same way. Your core right now is mission critical voice. That's analogous to your DB. This FirstNet's a great supplement. It can provide a lot of things and a lot of capabilities, but not at the expense of undermining your primary goal. I hope this kind of at least put some questions in your head, and I'm delighted to answer any questions, but I hope the takeaway here is that there's a lot of issues out here. You know, people are going to come by and hype this. Just beware, caveat emptor, you're the buyer, beware what they're trying to sell you.